Let's take a look at two problems in section 3.9, numbers 3 and 4. In both cases, we're to find the derivative. And these derivatives involve the natural log function. So just recalling what we learned in this section, the derivative of the natural log function, natural log of x, is 1 over x. Remember, we derived that. In fact, we derived the general derivative of the general logarithmic function with base a, which was 1 over the natural log of a times x. Since a, the base, is e in this case, and the natural log of e is 1, we just get 1 over x. And then if you take the chain rule, or the generalized rule here, the derivative with respect to x of natural log of u, where u is some function of x, you've got chain rule. Outer function is natural log of u is 1 over u times the derivative of that inner function. Or another way of thinking about it is just 1 over u times the derivative, or the derivative over u prime over u. You can think of it about it that way. And so when we think about this, that's exactly what we have here. What's the derivative of y equal the natural log of 4x squared minus 3? Well, 4x squared minus 3, that's the inner function u. And so we just got u prime over u. It's really the chain rule, right? So I've got outer function natural log of u is 1 over u times the derivative of the inner function 4x squared minus 3. Well, the derivative of 4x squared minus 3 is just 8x, right? By the power rule here, bring the 2 down, 8x to the first, and then the root of 3, remember, is 0. And so there's our result for number 3. Number 4 is, again, involves a log function, but this time we've got 3 times the quantity natural log of 9x to the 9th power. So I've got a chain rule here, got 3 as a constant multiple pulled out. Here I've got the outer function u to the 9th, and the inner function will be the natural log of 9x. So what's the derivative of u to the 9th? Well, that's 9u to the 8th, where u is the inner function here, but then times that inner function. And what's the derivative of natural log of 9x? Remember what we said, derivative of natural log of u is just u prime over u, where in this case our u is the 9x. And so the derivative of u prime is 9 over u is 9x. Well, 9 divided by 9x, the 9's cancel here, and we're just left with 1 over x. Right, so the derivative of natural log of 9x is actually just 1 over x as well. And so cleaning up my answer, I've got 3 times 9 is 27, and then I'm dividing by x. I have 27 divided by x times all this stuff, natural log of 9x to the 8th power. So this is the natural log of 9x times itself 8 times, so we want to write it in that form a little more compactly. So you might be wondering, well, how is the natural log of 9x derivative equal to 1 over x? Well, we kind of showed you that. You might also recall the property of logarithms. If I have to take the natural log of a product, that's the sum of the logs. And so the natural log of 9x would be the natural log of 9 plus the natural log of x. Well, what's the derivative then of the natural log of 9x? Well, it's the derivative of this, but log of 9 is a constant, right? You can take your calculator, take natural log of 9. It's the exponent on e needed to get 9. And what is the derivative of any constant? 0. What's the derivative of natural log of x? 1 over x. 0 plus 1 over x gives us 1 over x. So we get the same thing as we did here. Okay, that was just a little extra. Hope this is helpful on these two problems.